Now we're going on to question number 8. Here, we're being asked for an intersection. And to find an intersection, you want to get both equations in the y equals format, which they usually are anyway, and then set them equal. So here, that's as easy as saying 18 equals negative 3x minus 18 squared plus 15. And from here, there are a few ways to do this question. The first way I'm going to show you is the discriminant. So it's a quadratic situation. So we want to get everything on one side equal to 0. So we can take away 18 from both sides, and we'll have 0 equals negative 3x minus 18 squared minus 3. We can go ahead and expand out the x minus 18 squared. That's the same as saying x minus 18 times x minus 18. And we can FOIL that. 0 equals negative 3x squared, outer minus 18x, inner minus 18x. 18 times 18, negative times negative is a positive, and that gives you 324. Still minus 3. Distribute, actually combine like terms first. Minus 3x squared minus 36x plus 324 minus 3. And now, just clean this up a little. And now we can distribute the negative 3. Negative 3x squared plus 108x minus 972 minus 3. So we have negative 3x squared plus 108x minus 975. Now we can divide everything by negative 3 to simplify it, and we'll get x squared minus 36x plus 325. Now we can analyze all this in terms of the discriminant. So the discriminant is a piece of the quadratic equation. Now, if you don't already, you should know the quadratic equation by heart. X equals negative b plus and minus square root of b squared minus 4ac all over 2a. And the discriminant is this part of the quadratic formula. Based on the sign of the discriminant, you can have different numbers of solutions. So I'm going to make up some numbers just to show what happens. 2 plus and minus root 4 over 3, 2 plus and minus root 0 over 3, and 2 plus and minus root negative 4 over 3. So if the discriminant is a positive number, we'll end up with 2 solutions. Because if we were solving the quadratic here, it would be 2 plus 2 over 3 and 2 minus 2 over 3. So we would get 2 answers. If the discriminant equals 0, we'll get 1 answer because we're not adding or taking away anything. It's just 2 over 3. So 1 answer. And if the discriminant is a negative number, we'll get no solutions because you can't have a negative under a radical. So if we're in a quadratic situation and we're asked how many solutions there are, we can just go ahead and find out the value of b squared minus 4ac, which with these numbers would be negative 36 squared minus 4 times 1, which is in front of x squared, times c, 325. Now, where did I get all those numbers? A quadratic is in the format of ax squared plus bx plus c. So the a is 1, the b is negative 36, and the c is 325. Now we can do 36 squared, 1,296, and 4 times 325 is 1,300, and we officially have a negative number under the radical, so we have no solutions. So that's using the discriminant, but in this particular situation, it's one of the longer ways to do this question. So let's show you a second method for this question that'll be a little easier. From the original starting point, which was setting the two equations equal, let's just pretend we're solving here. So we can take away 15 from both sides. Then we can divide both sides by -3, and we'll have -1 equals x minus 18 squared. Then we can try to, and I say try to, take the square root of each side. And that's kind of a dead end because you can't have a square root of a negative number. It's one of the things that's forbidden in the world of math, unless you're dealing with I, the imaginary number, which we're not doing here. So we have a negative under a radical, which means there's no solution. And so we arrive at 0 solutions because there are 0 places where these lines would intersect. So that's method 2. Now method 3 would involve using the Desmos graphing calculator. Now you do have access to the Desmos graphing calculator for the digital SAT, but we recommend also bringing in a graphing calculator like a TI-84. And there are certain situations where your own calculator is better and some where a Desmos is better. Here, we graphed both equations in Desmos, and it's a little hard to see, but this is the y-axis, this is the x-axis. One of the advantages of Desmos is that you can zoom in and out really well. On a graphing calculator, it would take a lot longer to get it to exactly this scale, but you've got the vertical line, you've got the horizontal line right here, not vertical, and then you've got the parabola right here, and you can see that they simply don't intersect. Now, we did this question in the order of the most important methods for SAT, and that order is the idea of what occurs the most often, because the discriminant is a major concept on the SAT that you really need to know. Doing the actual solving is really important, and Desmos is a great tool that can't be ignored. But surprisingly, by having the graphing calculator at every step, really what it does is it creates a lot of uncertainty. So on every single question, you're constantly undecided about what method you should be using. So really, if you're following Gradeful for preparing for your SAT, you want to really lean toward the methods that we're leaning toward. On the easy questions, sometimes they'll require more work, but leaning toward these methods puts you in a position to be able to do questions in the ways that are going to help you on some of the hardest questions. But even though you have 3 ways to solve this, they all point to the same answer. These two graphs, these two equations intersect 0 times for number 8.